Well, hello again, advanced algebra students. We're ready to take a look at today's notes. So this is still on 13.6. It is on the tangent function and looking at graphs. A couple important things. First, a reminder that when you have a function of the form y equals the tangent of b times x or b times theta, it's the same thing, we can use x or theta interchangeably. Remember, the period of that function is pi over the absolute value of b. So the period there is the standard period is pi, not 2 pi. And also important to note that all of today's work is done with the calculator. So today's work is all calculator active assignment. So let's see how we're going to do this. So we've got 4 different types of problems we're going to do. So first, problem A is sketch a graph of the function y equal tangent of 3/4 x over the region where x goes from 0 to 2 pi. So let's go ahead, let's do this. So let's first we pull out our calculators. I'm going to need to turn off that light so you can see the calculator better. I think if I can move it like that. So first thing we'll do is we'll make sure that whatever I've got in my calculator here on my graph is gone. So I will menu here. I will go ahead and I will get rid of everything. And normally you are probably in your standard viewing window, which is here. So likely this is what your calculator looks like. Now, a couple things to make sure. We're going to enter these things. Whenever we graph, we always want to be in radians. So make sure your calculator is in radian mode. If you're not, you need to change that. You should know how to do that, but in case you don't, if you go to your home page there, and then you go over to settings, and pick settings, pick your second choice, your document settings, and there you'll see where it says angle, you can pick radians there instead of degrees. So make sure you're in radians. After you pick radians and hit enter, go down here, and you must pick make default and hit enter. It'll ask you something, you say okay. And now it's set for radians and you are ready to go. So let's go back to our graph screen. So here's our graph screen. So we need to enter our equation. So this equation is tangent. So we hit the trig button. Get our trig button there to get tangent. Hit it 3 times. Select tangent. And now we want to put 3/4 x. If you want, you can save yourself some time and put in 0.75 x. But you can also do 3/4. If you hit your fraction template, put in 3/4, and then you want to multiply that times x, and hit enter, and you will see your graph come up. Now notice, we only want this where x is between 0 and 2 pi. So what we want to do is change the viewing window so we only see between 0 and 2 pi. So under menu, go down to choice 4, window, and you want to take the first one where we can custom set it. And so you want your x minimum to be 0 and your x max to be 2 pi. Like that. Hit enter. And now we see the part that we want to sketch. We only want to sketch from here to 2 pi. Notice there is an asymptote there at 2 pi. We also have this asymptote right here, so we divide up our region between 0 and 2 pi accordingly. And we can figure out our period, which does help us if we want to sketch it. So our period was pi over 3/4, which is the same thing as pi times the reciprocal of 3/4, 4/3. So 4 pi over 3. So I know that my first asymptote is going to be from here to half of that, 2 pi over 3. So I know that's going to be my first asymptote at 2 pi over 3, and my other one's at 2 pi. And so I can go ahead and sketch what I see here on my calculator, looking like that. So there's my region just between 0 and 2 pi. That's what I'm sketching, is what I see in that screen. Okay, let's look at the next type. The next type says to find the period and sketch the graph y equals the tangent of -5/3 theta for -2 pi less than or equal to theta less than or equal to 2 pi. So now we want to sketch all the way from -2 pi to 2 pi. So I can show you a quick way to do this on your calculator. So let's put our calculator back here so we can see it. So I'm going to go back to my tab. I'm going to change this one. So I could delete that one out, or I could just change this one. Notice here on my fraction, I want my fraction to be -5 over 3. So I'm going to change this and make it -5. Now I could put the negative out in front. That also works. So if you don't like putting the negative in there, I could make this 5 over 3. Make that a negative in front there. So it's -5/3 x. Now remember, even though our equation says theta, all of our things we graph have to be in terms of x. So I must use x as the variable there, even though the book lists theta. Now I hit enter. But notice I'm only seeing this between 0 and 2 pi. If you hit your menu button and you go down to your window zoom choice 4, you have an option there called zoom trig. It's choice 8. It automatically goes to the window -2 pi to 2 pi. So if I just hit that zoom trig, I get the window that I want. And so now I have to sketch this. Notice it starts here and it's going down. Each one of these are going down. That's because there's a negative in front of this b here. So each one's going down like this. Notice it still goes through the point, the origin. And so when I go to sketch that, first I have to find the period. So finding the period, I know the period is going to be pi over the absolute value of -5/3, which is just 5/3. So sketching that out, that's pi times 3/5, the reciprocal, which becomes 3 pi over 5. So that's my period. So when I go to sketch this, it looks like this. So notice it does not go all the way up. It starts here part way, comes through, and it ends here part way just where I saw it in my calculator. You have to make sure you get the correct number of branches of this on each side. So the correct number of asymptotes or breaks in the function when you do that. So that would be your sketch. Basically just sketching what you see in your calculator. All right. The third type does not involve any sketching at all. It's a solve situation. We want to solve the equation 2 times the tangent of 1.2 theta equals -3. And we want to find all the solutions between 0 and 2 pi. So, once again, I should say it's a solve, but we are going to graph. But we're just not going to have to sketch any graph. But we are going to use a graph to solve this. So let's go ahead and let's take a look at how we're going to do this. So we're going to take our calculator out. We're going to get rid of the graph that we've got. So I'm going to go ahead and eliminate that graph. So let's go here to my menu. I'll hit the choice there to delete it. And I can go ahead and delete it. Now, I know what I would like to do here. The equation I'm going to graph, remember, is going to be 2 times the tangent of 1.2. And when I put that in, I have to use x, not theta. So I'm going to go 2 times the tangent. And this is going to be 1.2 times x like that. And I'm going to graph that. And so I get this. Now I want to know where this is equal to -3. So I will graph the line y equals -3. So now I'll just go ahead and graph the line y equals -3. And I know where those things are equal are going to be where they meet, the x values where they meet. So I only am interested between 0 and 2 pi. So I don't care about these 3 here. I only care about the ones where I start with an x of 0 and go to 2 pi. So that's 2 places that it happens at. So I must find the x coordinates of those 2 meeting points. So go ahead and use your analyze your graph, choice 6. And you want to ask for the intersection. So hit the intersection, and then it wants the lower bound. See, there's a lot of intersections. It's wanting to know where should I look. So you go there for your lower bound, you go to the left of where they meet, because remember, I want this meeting point right here. So I go to the left and I hit enter, and then it wants the upper bound. So I go to the upper side and hit enter. And it looks and it tells me that is the value there at that meeting point. Make sure your calculator goes out to at least 3 decimal places so that you can see your full answer, and you have 1.79, and then we round that up to 9. So one of our meeting points is 1.799. Now I need to get the other meeting point, so I'll do it again. Hit Analyze Graph, choice 4 for intersection, and notice now I'm picking out this point, so I'll make my lower bound to the left of that point, make my upper bound to the right of it, and hit Enter. Now right now, it's giving me both of them on top of each other. I can't see it. So what I need to do is come down here, use my little hand to grab onto one of these answers, lock onto it, and then move it up. So I can see that this point right here is going to have an x value of 4.41, and that's going to round to 7. So my answers then become theta of 1.799 and 4.417. So that's how I do that. Okay, the last type of problem asks us to write an equation for this graph right here. Well, I know the basic form. First off, if it's positive, it's going to be going up. That's what the tangent function does. This one is going down, so I know that it's going to have a negative in front of the tangent function. So I know it's going to be of the form y equals negative tangent of b times x. Now I just have to find the correct b. Well, notice here, this goes from 0, and it has its asymptote here. If I count this, that is 1/3 of the distance to pi. So that's pi over 3. So this whole thing here, it has a period of 2 pi over 3. See how it's got this? Takes 2/3 of the distance to pi to make a full cycle. So I know the period is 2 pi over 3, but I also know that the period is equal to pi over b. So I will go ahead and solve for b. Cross multiplying, I get 2 pi times b equals 3 times pi. Solving for b, divide by 2 pi, and I get b is equal to 3 pi over 2 pi. The pi's cancel, and I get b is 3 over 2. So then I just put 3 over 2 into my equation, and I get the correct equation. Y is equal to negative tangent of 3 over 2x, or 3 over 2 times theta. All right, that's how you do them. There's your homework assignment. It's 2 through 25, 30 through 35, and 44 through 46, all of those. And it's all calculator active. Okay, hope it goes well, and we'll see you at tomorrow's video.